Hello and welcome back. In this session, we will understand regularization. Regularization basically helps you reduce overfitting. When the model is overfitted, that's when the actual journey starts. The model is underfitted, you don't even try to go and test it on test set. When the model is overfitted, that's when you try to test it on test set. The model is working well on train set and test set. Equal accuracy you are getting on train set and test set. Then we'll move the model to production. In our previous whatever classes, we have understood the learning rate, the hyperparameter, to make the model converge faster. Like that, in regularization, we have got shrinkage parameter, which actually makes the model work well on both train set and test set. So when models are overfitted, that's when you regularize, and the regularization technique is useful when the model is overfitted. So what is overfitting? We already have seen it, but let us have a quick glance at overfitting one more time. So if the data is in a nonlinear pattern and you are trying to fit a linear model, it is underfitted. The accuracy on train set itself is going to be very low. If the model is nonlinear, having nonlinear pattern, and you fitted a proper curve through the data, it will work well on the train set and test set both. Right? It will give almost equal accuracy on train set and test set both. But while trying to find the best model, right? You built a linear regression model, you found underfitted model, you did second degree polynomial, you found a decent model, and in that quest to find the best model, you may have increased the degree to fourth degree. When you increase the model's accuracy, model's polynomial degree to fourth, the model may probably overfit, right? When the model overfits, what happens? It actually tries to understand the pattern of the training set well and ignores the generalization. So you know that there is a model between linear and the fourth degree which fits well, right? But you don't know which feature to draw. See here, actually you are given with only one x. You added x square, you added x cube and x to the power 4. And by the time you reached x to the power 4, you understood that the model is overfitted. And you know that there is a model in between, there is an equation in between the linear and the fourth degree, and you don't know that that equation has got x term and x cube term only, or x term and x square term only, or x term and x to the power 4 term only. In this case, selecting features is going to be very difficult for a human being. So if you use regularization technique, the regularization technique will nullify the coefficients which are not important. Let me try to draw and explain a little bit. In this particular case, we know that the second degree polynomial is the best. So we have to make, keep the model as it is and make this coefficient and this coefficient 0. Right? That model will actually fit well. That will become a equation like this, right? When you make the theta 3 and theta 4 0, it becomes a second degree polynomial. In the quest of finding the best model, you have actually fitted a fourth degree polynomial, and now you need to eliminate the features x3 and x4. While doing a model, you don't know, because in reality you will have thousands of features. Which features coefficient to make 0 and which features coefficient to make the highest, you don't know. If algorithm can handle it, that's going to be beautiful, right? So the regularization technique will know at runtime, it will know which feature to make 0 and which feature to make it high. That is called as constraining the parameters. These are called as parameters. Theta 0, theta 1, theta 2 and theta 4 are parameters. In some case, maybe theta 1 is 0 and theta 3 is 0, but rest are high. So in that case, the equation is going to be theta 0 plus theta 2x square plus theta 4 x to the power 4. Maybe this equation fits well, right? We don't know. So if you regularize the model, right, the technique will automatically make the thetas make the coefficient which are not important to 0, which are important to positively affecting the the feature or the model, make the positive, negatively affecting features negative. So this is called as regularization. So when there are three different techniques in regularization: ridge, lasso, and elastic net. Ridge and lasso are the independent techniques, and elastic net is the combination of both. So in the coming session, we'll try to understand how exactly the regularization is, finding which feature to make zero and which feature to make big or small. Thank you.